We're talking about the history of the atom, and our goals are to be able to understand the history of the atom as well as the models that were developed along our understanding of the atom. We've talked about Democritus, we've talked about Dalton, and how Thomson came in and discovered electrons and modified Dalton's idea. But the other thing that Thomson did was opened up the gates for people to really try to discover what else is in there. And another scientist by the name of Ernest Rutherford was playing with something called an alpha particle, a particle that was known to be positive. And he started shooting these alpha particles at all sorts of things. But his famous experiment is called the gold foil experiment because he shot these alpha particles at a thin piece of gold foil. And he saw something that was unexpected. Most of the particles went right through the gold foil, but a few of them bounced at really strange large angles. So he really had to think about what was going on. Only a few of the positive particles were bouncing. Most were going straight through. So he postulated, he came up with the idea that this means the atom must be mostly empty space. But because some of the positive particles were bouncing, the positive area of the atom must be really small because so few of them were. This led to a new idea, right? Thomson said that there were electrons and the positives were everywhere, but really Rutherford changed that picture to say the positive is actually a small amount only in the middle. And he called that area the nucleus, the center of the atom that is positively charged. And his picture became what is known as the nuclear model, a positive nucleus with the electrons orbiting around that nucleus. Now, from here, from the gold foil experiment, more experimentation comes dealing with light and how light interacts with matter. And other scientists like Niels Bohr started to discover that those electrons have kind of fixed energies or specific energy levels. What he noticed was that the electrons seem to absorb a certain amount of energy to move and come out of the atom. And from this, he postulated that the uh, model actually looked more like a planetary model, where you have a nucleus in the middle, kind of like our sun, and the electrons orbit around the nucleus in distinct energy levels. His picture wasn't too far off, but it neglected the idea that atoms are three-dimensional. And so from Niels Bohr, or since Niels Bohr, we now know that those electrons aren't just stuck in two-dimensional orbits, but in reality, they are in areas of the space that we call the electron cloud. And this electron cloud is made up of probabilities that we call orbitals. And this all gets kind of confusing for now, and we'll come to this later on in the course. But this is our current model that electrons exist in regions around the nucleus called the electron cloud and in orbitals. And here's kind of the overall timeline. Dalton said the model was solid. Thomson said, no, there are negative charges, electrons. Cathode rays showed electrons. Rutherford found that the positive part was actually really small. The atom is mostly empty space. Bohr started to see that the electrons had distinct energies, and now we know more about those energies and how they relate into three-dimensional space. And this is kind of the history of the atom and the models and where we are now. And throughout the course, we're going to learn more about how each of these models can kind of be used to think about a different part of chemistry.